Hello, welcome to MooMooMath, where we upload a new math video every day. In this video, I'd like to discuss adding with scientific notation. When adding in scientific notation, the two expressions must have the exact same base numbers to the exact same powers. In this example, notice you have the same base numbers and the same base powers, so you are good to start adding. In this example, notice that the powers are different, so you will need to make an adjustment to the coefficient in order to add. And finally, remember, after adding, the coefficient should be between 1 and 10 to be in correct scientific notation. In order to have the correct determination of accuracy, count the number of significant figures of each number in the problem. Next, add or subtract the numbers, and then round the answer to the least number of places of any number in the problem. And finally, for correct determination of accuracy, your answer cannot be more precise than the least precise measurement. Okay, let's go ahead and solve some problems with adding and subtracting with scientific notation. First, the rules apply, they're the same for addition and subtraction. In this example, I notice that the exponents are not equal. So I'm going to go ahead and lower this and make this 7.5 times 10 to the third. The way I remember to do this is if I lower the exponent, I need to increase the value of the number. So this number will, in order to increase the value, I need to move the decimal 2 places to the left. So it will become 7.50, because I've moved the decimal 2 places, times 10 to the third, and then this will remain the same, 2.05 times 10 to the third plus 750 times 10 to the third. When I add these two together, I get 750 2.05 times 10 to the third. Well, we now know that it is not in correct scientific notation because it needs to be between 1 and 10. So in order to do that, I need to move the decimal places 2 places to the left. So in order to do that, I decrease the value of the number, so I'm going to increase the exponent, so it becomes 7.5205 times 10, and I need to move it 2 places. 3 plus 2 equals 10 to the 5th. Okay, now to check accuracy. If I go back to my original numbers, I have 2 significant figures here, 3 significant figures here. So my answer must be in 2 significant figures. So if I draw a line here, I look at the next number and it is less than 5, so it will be 7.5 times 10 to the 5th. Okay, so there is example number 1. And next, let's look at the next question. And let's look at the exponents. And as you can tell, the exponents are not correct. So what I'm going to do is I'm going to make it 10 to the 4th, okay, because I think that number will be a little easier to add. So remember my rule, if I go down with the exponents, the value of the number must go up, and in order to increase the value of the number, I will move to the right. So I will have 5.603 times 10 to the 4th plus, and I'm going to move the decimal 3 places. Why 3? Because 4 plus 3 is equal to 7, so that becomes 3 times 10 to the 4th. Okay, now my 2 exponents are in good shape. I will now add them. 5.603 plus 3 is equal to 8.603 times 10 to the 4th. Our number is between 1 and 10, and so we don't have to adjust this. But now let's go back and look at significant figures. We have 4 here. We have, remember you count the zeros if they're have a decimal, so we have 1, 2, 3. So it needs to be to 3 spaces. So it will be 8.60 times 10 to the 4th would be our correct answer. And now let's look at the last one, which will be a little subtraction. And if we look at our subtraction, we look at the two exponents. They're close, but they aren't equal. So what I'm going to do on this one is go ahead and move the 7 to a 6. So again, I'm going down, so the number must go up. In order to go up, I move the decimal to the right because 90 is greater than 90. So I will have 90 times 10 to the 6 minus 5.705 times 10 to the 6. When I subtract 90 minus 5.705, that gives me 84.295 times 10 to the 6. Okay? First, we are not between 1 and 10, so we need to adjust the number. We need to make it smaller because 8.4 is smaller than 84, so that means the exponent will go up. And so that becomes 8.4295 times 10 to the 7th, because I had to add 1 to the 7th because I moved it 1 to the left. And now let's look at significant figures. Well, in this particular example, we only have one significant figure, so to be accurate, it needs to be 8 times 10 to the 7th. Okay? Hope that helps with adding and subtracting with scientific notation and making sure that it is accurate. Thanks for watching. Please share.